Hello, good evening everyone. Welcome to BYJU'S exam prep. So I hope that my video and audio is absolutely fine. According to me, I have already checked it, and from my side, it is working well. So I request you all of you to join the session because here I am going to make you learn the concepts and along with the detailed solutions. So quickly share the session with all of your friends and also tell that our sir has already come live and let's solve the new questions that might you have not solved before. And this is not from any textbook and the newly created questions. And also it is helpful for all the students, those who are preparing for GATE 24. Okay, so all the students, those who are preparing for GATE 24, it is going to help you. So quickly comment in the comment section if you have already joined. Comment in the comment section quickly, guys, so that we can start the session. And before starting the session, I would like to tell you that about myself. Yes, so one student have already come where I can see the concepts question. So Sheikh Rahim, actually there is the concepts questions, concepts you can learn from our app. BYJU'S Exam Prep app you can download from the link given in the description, and there you can access the theory concepts of the EMFT, and you can after that you can again come back to the question series if you are not aware about the theoretical concepts. Then you can learn. There are free of cost, some lectures are available, and you can access those lectures. Okay, ठीक है शेख. आई होप आपको क्लियर है ये वाला बात. और लेट्स स्टार्ट द सेशन विद द ब्रीफ इंट्रोडक्शन अबाउट माई सेल्फ. सो दिस इज साकेत वर्मा and I have done more than MTech from IIT Guwahati and more than 13-year experience. And I have also created different PSU exams and more than lakhs of students I have mentored. And so my area of expertise are electromagnetic theory, communication system, advanced communication system, signal system, and ICT. And I would like to tell you that if you are looking for the GATE 25 or GATE 24 crash course, then there is a scholarship on every Sunday from 9 a.m. to 9 p.m. You can access this scholarship test and you can register yourself on this particular scholarship test where you will get the 90% discount, up to 90% discount. And also there is a workshop tomorrow at 7:30 about the qualities of the toppers in which are going to be in the GATE 24. And these are some important announcement, like if you suppose download the BYJU'S exam prep app and if you come and participate in the quiz, then the leaderboard we will generate, and by that leaderboard you will understand that how many questions you are solving correctly and where is your position in the all among your friends. So in the GATE 24, uh, this is one more thing that about the crash course I told you, and the contact number is here. If you are not suppose aware about the contact, so you can get this contact number, call in this number and access and ask about the discount and the courses available and scholarship tests, etc., etc. Okay, and now coming to the questions. So this is the first question, and I think I should hide myself because you will not be able to see. For time being, let me hide myself. And I'm also creating the timer for you. Okay, so I'm creating the timer also. So here you will understand in this 4 minute you have to solve this question. It may be MSQ type also. Okay, it may be MSQ type also. So you have to answer whether it is MSQ or not. According to that, you should answer this question. Check the every option one by one, then maybe you will understand that whether it is a MSQ type or not. I hope that the question is visible to all of you. Which of the following field harmonics are out of 180 degree, out of phase by 180 degree with respect to the electromagnetic wave traveling in the material? So, out of phase by 180 degree. How do you decide that whether it is a 180 degree or not? By the mean of the reflection coefficient. Okay, by the means of reflection coefficient. So up till this 3 minutes, you have to check, and after this 3 minutes, I will start solving this question. Okay, because the question is not visible to all of you, so that is why I have I have hidden myself, and I will be joining in this 3 minutes. So hello Akansha, yes, try to solve this question. First option says that the incident waves from the dielectric and also reflected from the free space. So there are 2 minutes more to solve this problem. I have given you 4 minutes to solve this problem. Which of the following field harmonic are out of phase by 180 degree with respect to the electromagnetic waves traveling in the material? Second option says the electric field incidence from the free space to the conductor. C and D, Vashist Akansha is saying that their C and D are correct. Okay, so just wait for 1 minute to I will come with the right answer for this question. Akansha is saying the C and D both are right. Just 1 minute more, then I will come up with the answer and also with the detailed solution. Last 40 seconds, quickly solve the question. 30 seconds. Option C says the magnetic field incidence from a free space material to the reflected wave H from the dielectric of epsilon r equal to 9. And I think both the mediums are lossless only, right? So we can apply direct formula for the lossless. Yes, so I am coming back. Yes. Now let's discuss this problem. So the right answer for this question is option number B. Okay, the right answer for this question is option number B. So let's see how this option number A is right. So for the first option, I am checking with the first option. E is incident from a dielectric. That means there is a boundary. Okay, there is a boundary. The wave is incident, and this is the dielectric. Incident from the dielectric. Yes. So Akansha, wait. I am going to explain this dielectric, and this is the free space. Okay. So here epsilon R2 is 1. Here the epsilon R1 is 9. Okay, and the wave is reflected back. Now let's calculate the reflection coefficient. This is given by root over epsilon R1 because eta 2 minus eta 1. So this is epsilon R1 minus epsilon R2 divided by root over epsilon R1 plus root over epsilon R2. Epsilon R1 is 9. So root over 9 minus 1 divided by root over 9 plus 1. It is 3 minus 1 2 and this is 3 plus 1 4. So it is coming as 1 by 2. It is coming positive. So since the reflection coefficient is positive, the reflected wave and incident wave are in phase. Okay, in phase. Now coming to the second option, option number B, and E is incident from the free space. So the first second medium is incident from free space. This is the free space, and the second one is conductor. So if it is free space, that means again epsilon R1. Epsilon R1 is 1, and because it is conductor, so eta 2 is 0. So reflection coefficient is eta 2 minus eta 1 divided by eta 2 plus eta 1. Eta 2 is 0, so reflection coefficient is minus 1. Hence we can say that 180-degree out of phase. Okay, so this is the question. So option B is right, and let's check any other options. For C, H is incident from a free space material. So H, this is the magnetic field, free space material, that is epsilon R. First medium is epsilon R1. Okay, so this is epsilon R1 is 1 and reflected from the dielectric, so epsilon R2 is 9. So if I calculate the reflection coefficient for the electric field, so it is from the formula root over epsilon R1 minus root over epsilon R2 divided by root over epsilon R1 plus root over epsilon R2. It is 1 minus root 3 divided by means root 9 divided by 1 plus root 9. So it is minus 2 divided by 4. So it is equal to minus 1 by 2. This is the reflection coefficient for electric field, but we want to calculate for magnetic field. So reflection coefficient for magnetic field is minus of reflection coefficient for electric field. So the answer will be plus 1 by 2. So in phase. So magnetic field are in phase. Okay. Reflection coefficient for magnetic field are in phase. So option C is also wrong. Correct. Now option D, power incident. So power incident is given by reflected power divided by incident power is 1 minus mod gamma E square. So it will never be negative because gamma is always less than 1. So this is the incident from air and transmitted to the dielectric. So it is same as the option number C. So the reflection coefficient will be 1 by 2. So 1 minus 1 by 2 whole square. So it is 3 by 4. So it is also in phase because of the positive sign, and also the power will never be out of phase because of this mod, and the reflection coefficient will always be less than 1. Correct? Got it, Akansha? Now coming forward for the next question. I hope that you have got the answer, Akansha. Can you tell me? Have you understood or not? So answer this question. Sea water has mu equal to mu naught and epsilon is equal to 81 epsilon naught. sigma is equal to 20. The frequency at which the conduction current density is 10 times the displacement current density in magnitude is. Last 40 seconds. Akansha, have you got any answer? Yes. So the right answer is option number C. Correct. So here the it is saying that the conduction current density. So conduction current density is 10 times of displacement current density, and conduction current density is sigma into E mod of it, and 10 times of j omega epsilon naught E. Okay, so here because it is saying only magnitude, so sigma is equal to 10 times of omega epsilon E. So this E and this E will get cancelled, and it is asking for frequency. So let's write 10 into 2 pi f, and epsilon is equal to 81 epsilon naught. So f equal to sigma divided by 20 pi into 81 epsilon naught. So if I substitute all the values over here, so the sigma is 20 divided by 20 pi into 81 into 10 raised to power minus 9 divided by 36 pi. So this 20 and 20 will get cancelled, this pi and pi will get cancelled, and we will get 36 into 10 to the power 9 divided by 81. So 9 nines are 81, 9 fours are 36. So here we are getting approximately, suppose if 4000 divided by 9 into 10 to the power 6. So it is 9 fours are 36, 4, again 9 fours are 36, then again 44, we are getting approximately triple four megahertz if I am solving. So triple four megahertz, that is approximately option C. Okay, now answer this one. Which of the following statement is correct for this particular question? Oh, sorry, incorrect. It is asking for incorrect. Again, it could be the MSQ question also. Okay, so check all the options, and yes, this is obviously the beta. The value of option B, in the option B, it is the beta. h is equal to 0.1 e to the power minus 0.5x sine 10 to the power 8t minus 4x is at cap ampere per meter. Then which of the following statement is incorrect? It is asking for incorrect. Yes. So any answer, Akansha? Have you got any answer? ए बी सी तो आ गया बट डी चेक करना बचा है. ओके. तो ए और बी सी में कौन सा इनकरेक्ट है? सारे करेक्ट है क्या? ओके, लेट्स चेक. देखो, पहले तो आपको यहाँ से दिख रहा है कि मैग्नेटिक फील्ड जो दिया हुआ है, तो एच नॉट की वैल्यू 0.1 है. ठीक है, और ये एम्पियर पर मीटर है, कोई दिक्कत नहीं है. अल्फा की वैल्यू 0.5 है, नेपियर पर मीटर है. बीटा की वैल्यू तुम्हारा 4 है, तो ये तो करेक्ट है. ठीक है, और डायरेक्शन ऑफ मैग्नेटिक फील्ड कितना है? मैग्नेटिक फील्ड का डायरेक्शन है ए जेड, और डायरेक्शन ऑफ प्रोपोगेशन क्या है? ए एक्स. ठीक है. एटेन्यूएशन कांस्टेंट अल्फा 0.5, ये करेक्ट स्टेटमेंट है. सो बीटा की वैल्यू 4, ये भी करेक्ट स्टेटमेंट है. तो करेक्ट स्टेटमेंट ना, ये सारे करेक्ट हैं. ये आपका ऑप्शन ए करेक्ट हो गया, ऑप्शन बी भी करेक्ट हो गया. द वेव इज पोलराइज्ड इन द एक्स डायरेक्शन. तो पहले हमको इलेक्ट्रिक फील्ड निकालना पड़ेगा. तो इलेक्ट्रिक फील्ड का डायरेक्शन क्या होगा? तो इलेक्ट्रिक फील्ड का डायरेक्शन होगा मैग्नेटिक फील्ड का डायरेक्शन क्रॉस प्रोडक्ट विद डायरेक्शन ऑफ वेव प्रोपोगेशन. सो यहाँ पे आ जाएगा ए जेड, और ए के की जगह आ जाएगा तुम्हारा ए एक्स. तो ए जेड क्रॉस ए एक्स ए वाई आ रहा है, तो ये इनकरेक्ट हो गया. ठीक है, तो ये इनकरेक्ट है क्योंकि हमारा वेव जहां पे कहां पे पोलराइज होता है? वेव इज ऑलवेज पोलराइज इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. वेव इज polarized in the direction of in the direction of electric field. ठीक है, वेव कहाँ पे पोलराइज होता है? जहाँ पे इलेक्ट्रिक फील्ड होता है. अब बच गया टाइम पीरियड. टाइम पीरियड निकालते हैं. तो टाइम पीरियड यहाँ से ओमेगा की वैल्यू है हमारे पास है. ओमेगा इज इक्वल टू 10⁸ दिया है, तो टी इज इक्वल टू हो जाएगा 2 पाई बाई ओमेगा. सो 2 पाई अपॉन 10⁸ 8. तो ये डेफिनेटली 1 माइक्रो सेकेंड तो नहीं ही आएगा, है ना, क्योंकि ये 2 पाई इंटू 2 पाई डिवाइडेड बाई 100 इंटू 10⁻⁻6 आ रहा है. तो ये आ जाएगा तुम्हारा 6.28 है ये. तो 6.28 के आसपास आपका आ जाएगा 62.8 नैनो सेकेंड, है ना. 62.8 नैनो सेकेंड आ रहा है, जबकि गिवन कितना है? ये भी, तो ये भी इनकरेक्ट हो गया, है ना. ये भी आपका इनकरेक्ट हो गया. तो आपका आंसर क्या आएगा? ऑप्शन सी और ऑप्शन डी. ऑप्शन सी और डी. ओके, चलो ठीक है. क्वेश्चन इसलिए मैं आपको बोला था, 2 3 बार मैं बोला भी था कि इनकरेक्ट बताना है, ध्यान से देखो करके. शायद आपने ध्यान नहीं दिया. चलो, सॉल्व करो. Okay, so what is the answer? C? Yes. So here the because the Brewster angle is given, so we know that the Brewster angle is tan theta b for parallel polarization is root over epsilon of the second medium and epsilon of the first medium. So this 1065. So this is 1065. The parallel polarized wave from air to dielectric. So it is going dielectric and then air is 1. So 1065, when we square it, we will get 10 square 65 is equal to epsilon r2. Okay, so 10 square 65. What is the value of 10 square 65? 4.57. So epsilon r2 is coming as 4.57. So approximate answer is 4.6. Correct. Now answer this. 'The electric field of an electromagnetic wave is given by the polarization of the wave, left circular. Okay, we'll check that whether it is a left circular or not. So, according to the question, if I go through the shortcut, the wave is propagating in which direction? The wave is propagating in the minus z direction. So, suppose this is x, this is y, the wave is propagating in the minus z direction. The wave is propagating in the minus z direction. The phase of x component, the phase of x component is minus 180 degree. Sorry, but the 180 degree. Okay, and the phase of y component is 0 degree. So the phase of y is leading. This is leading because it is positive angle. This is the negative angle. You can say. Okay, 180. Okay, no, actually I should say this is 180. So I should say that is a leading. Okay, y is leading because it is 180 degree. Positive only I am taking. Okay, so it is leading. This is lagging. Y is lagging because the Y has the phase delta y, phi y. That's right. This phi y is 0 and this phi x is 180. So It is leading. Now when you go from the lead to lag, this is how we calculate. So lead to lag. So lead to lag is yes. So it is satisfied by the left hand because the thumb is inside the screen and the left hand fingers are rotation of the left hand fingers are in the direction of rotation of the field. So यहाँ पे आप देखोगे तो ये जो फील्ड जिस डायरेक्शन में रोटेट कर रहा है उसी डायरेक्शन में लेफ्ट हैंड फिंगर्स भी रोटेट कर रहे हैं. तो इसलिए ये क्या आएगा लेफ्ट हैंड सर्कुलर करेक्ट. ठीक है इसके बाद आपके एंटीना के क्वेश्चंस भी आएंगे. Just last 1 minute, Akansha. C. Let me check whether you are correct or not. After 20 seconds, we will come up with your answer. So, right answer for this question is option number B. So, here we know that the eta is E naught upon H naught. We want to calculate the associated electric field. So, that means E naught is equal to eta into H naught. And first field okay, for first component I am writing E naught is eta is fixed 100 and E naught is 10 and it is in milliampere. Okay, so it is in milliampere. So 10 is per minus 3. You will get 1 volt per meter. What is the direction of electric field? So the direction of electric field is the direction of magnetic field cross product with direction of propagation. So the direction of propagation is x and the magnetic field is having y. So ay cross ax is minus az. Now for the second wave which is having the 20 magnitude, so E naught is 100, that is eta into 20 into 10 to the power minus 3. So it is 2 volt per meter. And then electric field direction would be the direction of magnetic field which is Z and the direction of electric field, direction of propagation is x, so z cross x is y. So it is having the positive y direction and negative z. So positive y, negative z with the magnitude 1 or 2. So answer will be option B. Got it? Option B will be the right answer. Correct? And because it is saying that it is associated electric field, so the wave will be in the same direction. Wave will be in the same direction. It will not change its direction. So option B and C are having only two difference, one difference, that is the direction of propagation. Yes, only the direction of propagation was changed in option C. So I think you thought of writing the electric field, but maybe if you are writing a reflected field, then how it is possible now without calculating gamma? A 15 megahertz uniform plane wave propagates through a lossy material so that it has a phase shift of 1 radian per meter and its amplitude is reduced by 12% after every meter travel. Then attenuation constant of the wave for t equal to 1 second. What is the answer? What is the answer? Akansha? Okay. So it is very easy question because the amplitude is reduced by 12%, means it is 88% left of the maximum value, and E naught e to the power minus alpha z. So E naught and E naught will get cancelled. So 0.88 is equal to e to the power minus alpha z. If I take the natural log, so natural log of 0.88 is equal to minus alpha z natural log of e. So here it is, if you take this 0.88 natural log of 0.88, it will be 0.127. So alpha is equal to 0.127 because it is saying in ampere per meter, so that is the answer. And it is also saying that every meter, so z is 1 meter, z is 1, okay, because it is saying every meter, so z is 1. So answer is 0.127. Now solve this. Yes, last 50 seconds. What is the answer? Akansha, what is the answer? Consider the diagram, all the symbols and notations are having their usual meaning. The power density of reflected wave, and that only we want to calculate in the magnitude. So the right answer is option C. Right answer is option C. See, this is the first medium, this is the second medium. So can I calculate the reflection coefficient, because it is asking for the reflected wave. So we have to calculate the reflection coefficient. So eta 2 minus eta 1 divided by eta 2 plus eta 1, that is 300 minus 100 divided by 300 plus 100. So it is 200 divided by 400, so it is 1 by 4. So reflection coefficient is 1 by 4. Now the power density, so power density, to calculate the power density we need a electric field. So of electric field of the incident wave multiplied with eta. Incident wave has the electric field magnitude 10. It is given as 10. So 10 into 1 by 4. How much it is? 5 by 2. Okay. Is it clear up to this point? So 5 by 2, 300, 1 by 2. The reflection coefficient is 1 by 2. Na? This is 200 divided by 400. Yes, 1 by 2. It is 1 by 2. It is 1 by 2. So it is 5 only. 10 into 1 by 2, it is 5. So reflected field is 5. Now we want to calculate the power density. So power density is pointing vector magnitude only we want to calculate. So E R naught is square divided by 2 reflected wave, that means eta 1. So E R naught is 5. 5 is square divided by 2 into 100. So it is 25 divided by 200. So it is equal to 1 by 8. So 1 by 8 would be the right answer. Got it? Akansha, is it clear? Power density of reflected wave. Next, answer this. I'm hiding myself because maybe you are not able to see this diagram. So I'm just hiding for 2 minutes. So well, very simple diagram that is actually not required, but yes, you can see once, and after that we can solve these questions without any confusion. The region one is having the dielectric constant mu1 epsilon 1, incident wave E1 plus H1 plus, reflected wave E2 plus H2 plus, the transmitted wave E2 plus H2 plus. Okay, so the reflected wave is incorrect here. It should be E1 plus. This is E1 minus H1 minus E1 minus H1 minus, and then E2 plus H2 plus transmitted wave. Okay, so I think now I can come back because there is nothing special in this question, in this diagram especially. Yes, Akansha, answer is coming as 9. Okay, yes. So your answer is absolutely correct. So it is saying that if the amplitude of the reflected E1 is one half of the reflected E1 minus is one half of the E1 plus. So it means that the reflection coefficient, which is the reflected wave divided by incident wave, is 1 by 2. Now we want to calculate the relative permittivity. So because the second medium is also normal incidence and the non-magnetic is also given, once we can assume because only permittivity is asked. So this is 1 by 2 is equal to root over epsilon r 2 minus root over epsilon r 1, and let the region 2 z greater than 0 be the free space. Okay, so let me write the formula. So region 1 is free space. So 1 minus root over epsilon r1 divided by 1 plus root over epsilon r1. So 1 plus root over epsilon r1 is equal to 2 minus 2 into root over epsilon r1. So it is 3 into root over epsilon r1 is equal to 1. Uh, why there is a mistake? For epsilon r1 is unknown. Wait. Okay, yes. The formula I have written in this way. Wait a second. This formula is incorrect actually. This is 1, this is 2, because in terms of epsilon r I am writing, not in terms of epsilon. Yes. So epsilon r1 will come here, epsilon r2, epsilon r1, epsilon r2, epsilon r2, region 2 is having the free space. So let me clear this also. Then this is 1 by 2, the region 2 is unknown. This is 1, this is root over epsilon r1 plus 1. So 2 into root over epsilon r1 minus 2 is equal to root over epsilon r1 plus 1. So it is 3 and root over epsilon r1. So epsilon r1 is equal to 9. Yes. Epsilon r1 is equal to 9. Absolutely correct. Now I think I hope a question of an antenna. Yes. Now the antenna questions is coming. RHEP, how it is possible? Both are having the amplitude equal. So here is the second previous question I am getting right in, because the wave x component has phase 270 degree, which means it is lead lag by 90 degree. No, Rituk, I think we will move into that question again. Then I will explain. Let's solve this question first. An antenna has the maximum radiation intensity if the directivity of the antenna is 16.53, then the radiated power is. Direct formula based question from the topic antenna. Yes, so right answer is option C. So the formula is the directivity of an antenna is given by 4 pi into maximum radiation divided by power radiated. So we want to calculate the radiated power. So radiated power is equal to VIT is good college, good institute. Yes, VIT you can opt if you are looking for MTech, because one of my student has already got placed in Intel from the VIT doing MS Tech from VLSI. So it is definitely good if you get the VLSI only, and maybe or some more core branches like it, communication or signal processing. Then it is good. For other branches, it is not that much good. So after solving this, you will get 1.52 watt. Answer is option C. So which question you are saying? This one you are saying. This one you are talking about? Rutik, are you there? So you are saying that it is 180-degree phase shift, correct? So 180-degree phase shift plus 90-degree you can add, plus the 90-degree you can add. So this is 270. So 270 is again greater than the 5y. 5y you are having the zero phase, and 5x you are having the 270 degree. Okay, so since the amplitude are equal and the phase difference are in the multiples of pi by 2. It is odd multiple of pi by 2. Odd multiple of pi by 2. Okay, if follows odd multiple of pi by 2, then it is definitely a circular polarization. So it is definitely a circular polarization if the phase difference is odd multiple of pi by 2, and along with the direction of propagation, you have to check for the left and right. So x component is still leading and y component is lagging. Okay. DIAT and VIT is VIT is better. Sir, one more question, that what is the difference between in doing the MTech from IITS or from IITs and or from the university? See, BITS DIAT Pune, obviously in the placement terms of view, point of view, IITs are better, and some other universities like BITS and VIT, they are having better placement than some of the IITs, not all. And the research paper they push to publish you. These are the important benefits that you get. The tag of IITs are important. Okay, the old IITs especially over these universities like BITS, DIAT, and VIT, the old IITs are having better placement, better infrastructure, better professors, and uh, academics. So these are the benefits of getting the doing the MTech from these type of IITs, and some of the new IITs like Bhubaneswar, Gandhinagar, Patna, Mandi, in Hyderabad, all compared to these IITs, these BITS and BITS is better than all these IITs. And if you talk about the VIT is a private university. Obviously, it is having a good placement, but in not all the branches, only in the some of the branches. Okay, so that is why this is the difference that you will get. Okay, guys, so thank you for watching this session. We will meet tomorrow again with the new sessions. Okay, we will meet again tomorrow. Thank you. I think it is hanged, so we should stop. Thank you.